This paper is with title is space time black code simple is STBC with no vanished vanishing determinant this is NVD. This engineer is like to simple for P U P2V d square number of transmit and antennas. And this paper was joined with by some people. This topic is my new topic about coding. In fact, I already is interested in number theory, so now it's coding. But I use the number theory invest is coding. Coding is in fact I think coding is number theory, algebra, geometry, file field is invest coding is very good. 好，let's introduction about this topic. Introduction. This I gave a model about these things. Aqueous, static, real, relay, fading. This word from engineer world, and new table, import, and output, channel with NT is transmit, and NI is receive, antennas. This mode. This is engineer things. We are interested in mathematics, so we can translate translation mathematics model as Y matrix in R time L equals to H in R times NT time X in I times L plus W in I times L. Where L is continuous. This model is very used very more. For example, model, TV, anything is using this model. Where is L? Where L? This is this receive antennas. This is NT is transmit emitters. Where L sometimes is says is time snaps. Sometimes 1 second, 2 second. This is L. Some people is says this is channel use. Channel use. These other people says not says. This is a matrix NR plus L NR times NT matrix. This is I says what says W NR times L is additive noise matrix. Because we transmit signs, sometimes we can in some noise relation matrix. All elements belongs to complex. All entries belongs to complex. So this is a fixed matrix. This is a fixed matrix. We want to get to this matrix. This is vary. So the collection of all possible transmit code word transmit code word X L T times L for a space times black code for a space time as space time black code or sometimes S T B C. This collection is a matrix. Sometimes finite, sometimes is infinite. It's just you want to. Sometimes this is coding is this is infinite, and this is code words. Sometimes is finite set, sometimes is infinite. finish it. If you want. This is from engineer model, but STBC is invest in this matrix. In fact, we want to invest in this matrix. We always retract this supports. This is STBC. This is ST topic. Sometimes is supports condition where that's LT equals to L. This is square matrix. This we like to these things. Two and element instruments. Yeah, so it's absolute value interest. Sometimes we like is small. Sometimes it was large. This is engineer says this is a value is relative to the energy. First, some people invest in this topic. We want to. This is square matrix. We want to determinant x LT L LT this equals to n plus n. I always no zero for all x and n. This is recent investigate, but I not of things about STBC. I think this is some people interest these things. Okay, why number series interest is STBC? That's important things in these things for some number series interest in things. Okay, let's introducing these things. Maybe all people investigate number series will know this block group. Some people invest STBC use block group investigate these things. Second two, STBC based on cyclic algebra. Maybe I want to, I don't know, block over. Maybe it's right. Don't know. Your group is a quadratic form is a block group. Block group is a Hebrew symbol, and the things is relation cyclic algebra. Let's introduce cyclic algebra that K F D cyclic Galois Galois extension. Galois extension F degree n G is Galois group K F equals to sigma. I give cyclic algebraic D K F and is relation sigma relation gamma always is since okay is since is this algebraic algebra over F is field, K is field, KF is cyclic extension. Where is algebraic is not this is don't need number of field. Any general field is okay. This is cycle algebra. F is the center. F is the center. Center of D. Maybe in this side algebraic is in 1940. Hua gave you something research. Is Hua Gaodang research about center. I read this Jacobian basic algebraic says Hua research. I think so. Says F is the center of D algebra. K is a maximum. Next time, yeah, a maximum. No, is the maximum. Maximum is not a maximum of subfield. Maxima subfield FD. Then D is right vector space. Right vector space of K. Right of space K. Okay, this is algebra. Okay, conjugate. We construct algebra. We conjugate. And then Galois K, F is Galois cycle extension is okay, occurs G sigma is the cycle. Order is order n. Okay. D we can, this is a vector space. We can also be write K plus Z K plus Z n minus 1 K. This is vector space. Where K, where Z belongs D. This K this relation. Any K belongs to K. Z. K Z equals no, this is common.
D over K is N.
K N. Why K N? N is yeah N. Yeah, maybe is exist. Maybe is N is maybe is. Okay. Z is sigma K. Is gamma action. And Zn equals to gamma belongs to F. This is algebraic. Okay, I give some. I want to give you the condition. This is the important condition. If these things gamma, if gamma satisfies the condition, this is a condition is always paper is about this condition. Okay. Gamma I not belong to normal KF K for 1 high N and gamma N belongs to T is KF K. It is it's only choose gamma. Normal is equal to this condition. This is important. This is I is 1 minus 1 N is this condition. Okay, and this algebra I can give you an example. For example, e.g. Okay, e.g. This is we know is algebraic is D R real plus real I plus J R plus K. Yeah. What I think so. We all know I J I equal square J square K square minus 1. Then the J I J equals to K. Okay. For this formula is F equals to R. K. You maybe always is write R plus I R is complex always. We can also choose R GR. So I just says max not to three max subfield. Okay. This is I know is algebraic. Devise algebraic. Why is devise algebraic? Because his satisfies this condition. This is Z. For example, gamma. We can also choose minus 1 belongs to F. Gamma belongs to F. Gamma is gamma is gamma, which is satisfy star. Satisfy this condition. We can also this formula is Z. Z is just we can choose J. Okay. Choose J. Just is this thing is D equals to k plus j k. Let's see from this example. So this is algebraic generalized. Okay. This is algebraic. I think we all know this algebraic. This is my topic is about these things. When number theory is interested in these things. D. Yeah, I see. So this condition is device algebra. Yeah, you said right. It's only this is only it's just as it is algebra. If satisfies this condition is device algebra. Okay. Element gamma belongs F. Gamma belongs F. Satisfy star. This star is very interesting things. Is called normal element. It's called element. Is D K F sigma gamma is algebra. This is standard algebra. This device algebra is a device algebra. If and only if gamma is no normal element. Yeah, these things. This is interesting. These things is we want to give device algebra, but just the model is for matrix, so we can want to give algebraic matrix representation. Okay, I will give representation. For example, defined. Because this matter is we want to matrix. This D is algebraic, so we give D the matrix representation. Okay. Define eta D. Inject and K D. Just as D is finite, is right vector space K. So when this set is all the linear transform ring. Linear transform ring. Okay. With D X inject. This just inject lambda X. Where lambda X? Let X is regular transform. D into D. Just D infinite X D. I think it's time. Okay, I'll give matrix. Okay. Which matrix is very simple. I invest Limbo theory. I forgot algebra. In fact, I first invest algebra, then I invest Limbo theory. this is okay for repetition. N x forgot wait. Okay, if x belongs to I equals to 0, a minus 1, zi xi belongs to d, just the repetition. We can also lambda x 1 z a minus 1. This is base, and this we can get a matrix 1 0 z n minus 1 m. This we can also know these things. This is linear algebra. Linear algebra, M matrix is just x0, x1, x n minus 1, gamma, sigma, x n minus 1, gamma, sigma, x0, gamma, this is sigma, x n minus 2. This is gamma, sigma n minus 1, x n minus 2. Sorry, 1. Gamma, sigma n minus 1, x2. This is gamma, sigma n minus 1, x0. This is matrix. So we can also x with relation lambda x relation n. So this is just some things. This is just we told me is x is a matrix. M is x is m. This is something. And this thing is just give STBC coding. Why we give this coding is because this is a lot of things, a lot of facts. We give some interesting facts. We have some facts. First, 1. Determine n. Determinant belongs to F. 2. Determine n if equals to 0. Sorry. This is we must suppose these things. I think I say this is device algebra. Now we always we support suppose this is gamma is no normal element. Just says we want to say this is a device algebra. This is equal to 0 if and only if x0 x n minus 1 equals to 0. This is the condition. This is very interesting. So why engineer use this matrix give STBC. This is why use these things. Okay. We also if we want to give applications, if F choose QI, KF, this is SAC, side Galois extension, and x1, xn minus 1, this matrix belongs to K, and gamma belongs to F. F we want to use is device algebra, so we want to suppose is no normal element. These things is just number theory interesting things. It is no normal, and this is no normal. This is no normal, and also this is cycle extension. So we can also use some people use class field theory in investing these things. Class field theory. Class field theory just says cycle, normal things. We also use cycle, and these things we satisfy and is Minkow's Hansen normal theory. Just this. Why I interested in these things is just this cycle. We can use Cardinal theory invest in these things. Okay. Sometimes in this element we invest OK. Gamma is always infinite OF. Then we can get this is suppose we can get determinant n is internal element is matrix is determinant is integral algebra. So this is this determinant just says belongs to F, so can also belongs to O F. If it's not O zero, then these things is just this set. You need these things, so we can get determinant absolute must be belongs to 1. This is why is 1? I just some people some student ask me is why you choose immanage quadratic field. This is important things. Yeah. It's important thing. Even why some people why choose square? Why choose? Because if this things is absolution, and it is not these things. Why choose immanage quadratic field? No. Some people will ask me is why need these things. Is from STBC is communication. Wireless ask me need these things. This is very interesting. Okay, this is introduction. We also now this because we always interested in number theory, so we can invent these things. Okay, these things. It's just the background. Okay. I'm interested in some people work about non-normal element. In fact, this thing is only number theory TSA is very interesting. It is very important things about these things. So I'm interested in some people this care step. These things. No normal determine how to determine gamma no normal element. This is very interesting. Is for my number theory is also interesting in things. Okay, I'll give some people work. First paper is T Karen S Nanjing India. His paper is published REE. Transaction information Sarah volume 51 number 8005. This is edit. This is edit. Just is edit. Is write a note paper about STBC. I don't know. This is not clear. Number 3 is clear. This is engineer. I don't know. A note paper. But this paper is a note paper about number 3. So I like read newspaper. He gave this reset. This mail reset. If that is okay, also okay, that P is P B apply idea FF and P B apply idea of K over P F that F equals to F P what's SS B the initial degree. Okay. He support if gamma not belongs to P minus P2, yeah, and F P initial degree is equals to N. Sorry, this is K F K cycle, and this is cycle Galois extension, and K F degree N degree N. This condition, then gamma and gamma is no normal element. Just says gamma is satisfies this condition. So gamma is satisfying the condition. We can also say that that D is K F sigma. Sigma is parallel extension, and is gamma is deviation algebra. Deviation algebra. Deviation algebra. This is ranges. We also ranging gave example. Gave some example. Gave some example. He gave three cases. Three cases. Cases. One is Q theta 2 K plus 2 Q I sigma gamma takes 2 plus I. This is just we can say we can write this is diagram. Q theta 2 K plus 2 Q I Q. Give these things. I got K also gave this is theta Q plus K plus R. Also the changing is Q theta Q square Q. Is Q equals to 4 modulo 4. Yeah. So just like I said, why choose Q equals 3, 4? Just this condition. Not choose Q equal 1. Equal 1 is just Q square Q. So we cannot get this condition. Okay, this other case. Okay. Other things is he want to give this determinant n at least 1. It's two paper, recent paper, a new paper. Is Chinese right paper. Gao and Xia and Xia Xiang Gen. His name is Sang. His right a not auto paper. Very poor. He is interested in STBC. He's graduated from Nanjing University. He's now in America. He's not in America. He's not a paper. His paper title is element. This is a student. He's a student. Yeah. Graduate condition for normal elements. His published IEE transaction information server. Server is value 5, number 3, 29. This new paper. This paper is just use newspaper reset. He gave I'm not time. I just say some talk about. He just gave L is equals to mail reset. Mail reset is mail reset. Theta p. So theta p. Then we can give E is total real subfield Q theta p plus theta p minus. Then can get Q. He gave this idea is Q I. This is E K E I. They just gave this is idea. And this is extensions N. Is extension N. This extension is just new things. He gave this is formal. I am with her now. Let's introduce our paper. Our paper is changing these things. This thing is P. Is P. We can choose M equals to P1 mu P2 V. But AR equals to Q theta P1 U P2 V. It is very sorry. Is Q is not a cycle. So you want to give a subfield just in this cycle extension. So we can give this is L1 Q theta P1 U is give L2 equals to Q theta P2 V. This is cycle. This is cycle. We give E subfield. We can give E subfield. We can give E2 subfield E. This is cycle. This is cycle. I want to get together is E is a cycle. Cyclic. We want to give these things. We must give suppose. Suppose D just equals to GCD by P1 U by P2 V D. We can this cycle is N1 N2. I want to N2 put together is a cycle, so we can want N1 N2 is GCD equals to 1. We get this reset. So we can get N1 N2. It is easy. You can just we can D put into D. 1. This is just as N1 equals to N1 equals to N2 equals 2. Put together is E. Is what. So this is cycle, and this is very easy. Very easy to get this subfield. We can give. I use is sha reset. Sha reset is just E Q I K E I K. So we can give this reset. Also, this so we can get K, F, sigma, gamma, N. N is N just is says is N. Is division, algebraic. You see. We also list. This is P1, P2. So we can also give list. We take. We want to take gamma equals to 1 minus I. Because this is absolution value is smallest. Is smallest. Smallest in Fi. This so we can list old P1, P2 at most when 0, and D is D. D we can also D equals to 2. 4. Okay, we is tap. Is with base together work. At last, we also can do watch something. This I will not recently we investigate these things. This things is just told me is if this condition we get this condition. It just says this condition we get this a normal element. We want to give more beautiful condition to give this. And now we also give have get some interesting reset. We can also give some beautiful reset. But these things, I think this already these things is for number 3 is interesting things. Okay, stop here.